All right, so what we have here is like a 120 Neo arrangement with cubes and the rotor here. We've got one Neo washer magnet. And you can see how it's affecting the rotor. Bam. All right, so let me explain it real quick how I have it set up. I got all north facing in there. They're all north facing out. I got my pole sticking through my nail washer. So the pole is polarized. That's what's going on with the pole. So I got my nail washer. I got my iron pole sticking through it. And that whole pole is now north. But what we're going to do is we're going to put our magnet like that. We're going to have the south on that side, north on that side. So it'll attract and then it'll push. Happy Friday, Daniel. And you can see how it works when it gets slow. It's supposed to go slow. But when the slower it gets, the more you can see it work until it stops. And then you can't see it work anymore. But so it attracts and then it pushes that one. And they're spaced out just enough so that it will work. So it'll like attract and then push, and then before it attracts the next one, or right as it's attracting the next one, it'll be pushing. So that's how it works. And there's no monopoling going on right now. But you know, this pole right here is mono polarized when I shove it all the way through the washer. See? And it's definitely repulsion, because when it gets close, it stops. It starts pushing. It stops because it's pushing on it. And then if it has enough to push past it, it'll get a good knock if it gets past there. So, but I like the north-south bit here like this. I like this better because there's no like masking going on or any monopoling, and it's just kind of pushing and pulling it. It will stop. It's not designed to go on forever, but it's fun to see how it works. So I got my little magnet detector here. North, north, north. See that it's working. This is the north side of the magnet. Now, push it all the way through like that. Boom. That whole pole right now is, well, it's polarized is what it is. It's not a magnet really, it's just polarized. There's no field. You notice how I got to put the tool like right up on it to get the reading, is because there's no field. It's just polarized. right. Now, no doubt the magnet is in influence right now, but we can back it all out, and I'll show you. Just putting the polarized metal in the field of the other magnet, really, it changes everything. Now that's literally like a foot and a half away with the magnet. And I'm not saying there's no interaction there. There probably is, honestly. But we can back it out a little farther. Like have the bare minimalist interaction possible between the pole here and the outer magnetic, usable magnetic field of the neo cubes. So that's monopole right there. That's nothing but north on that pole. And I'm putting that pole in the north field of the magnet. But, you know, since it goes like this, the field goes like this. So out the pole and it goes out both sides. But everything on this side of the hemisphere, hemispherically, is north. On this side, it's not north here and south here. It's not how it's cut. It wraps around, but it's north up here and south down here. So, you know, polarization, poles. But yeah, it does wrap around for sure. Now let's see here. South. That's exactly the way I want it. Now half the pole is south and half the pole is north. Um, it's a permanent magnet. It's not a motor really. It's just a toy, and it's permanent magnet motion machine. I guess it's not permanent motion machine. I wouldn't say that perpetual or anything. But this Neo washer right here, it's got south this way, north this way. All those are north. Okay, so I just pushed a little bit with the magnet, and I haven't touched the rotor yet. So and the north comes around and gets attracted by the south side, which is that way, comes around. And then when it gets on this side, it gets pushed by the north side. See, and when it gets really slow, you can see it work until it stops, like really good. And there I touched it for the first time. But you saw that it had stopped, yes? I'm not really looking for pendulum effects. So if it starts going the other way, we're just going to consider it stopped. Now we'll flip it, I think. Yeah, it's flipped. Maybe. I haven't put any like practical thought into it. I've just been having a good time with it. Now, I bet when it gets slow this time, it's going to have a different reaction. I'm dying to see what it's going to do because now north is on this side and south is on this side. Looks like it's still working pretty good now, like pretty well. interesting. Wow, that is really neat. I wonder why it's still moving so well. It's awesome. Thank you, guys. Yeah, man. It's just I don't know, man. Maybe watching grass grow is fun sometimes, but God, it's fun sometimes. And I mean, technically, this is kind of what we're doing with how slow this thing is going, but you can see it work now. Like it'll line up with this. Let me line it up for you. Boom, 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 boom. And it gets pushed, like literally pushed. And it might be because the resistance lets up. And I think that's really what it is that there's like a stopping mechanism. Because I think and it's exactly what the problem has been the whole time, for any perpetual motion machine anyway, is that when it passes this point right here, the south starts to show its ugly face with these magnets right here. But what I've been wanting to do is monopole like this, literally monopole, have these washer magnets on the outside of this rotor and have the poles in those magnets as well. And I know there's no field, but I'm dying to see how those would interact just for fun, you know, if they'd interact at all, because yeah, there really isn't a field. But let me think here. So this is attraction right here. This is south. No, that's got to be south right there. Holy smoke. Yeah, that's south. We'll back it out. We'll start backing it out. And I didn't check it. That's why I was confused. But I can tell right now that is an attraction photo phase. There's a Neo washer magnet on the end of this pole. And let me show you how it works, kind of. That's south face of the magnet, right? Now this whole pole should be south. Now you can range the magnet and just have the pole in the field of the other Neo, and it'll interact with it. Monopole style. There's no like interaction with the other pole, but there's no field coming off of this rod. You see, it's just polarized. Oops, sorry. Didn't mean to get off point there. See, That's kind of weird to me. I'm just having fun, man. I'm just doing my thing, dude. Sorry, I can't give you a more crisp answer than that. I know you think I'm trying to do something that can't be done, but I'm not. Just by how you ask the question. Heck yeah, do you see it? Do you see it work though? I mean, that's what it does. It's just this side is north, this side is south. And when you spin it this way, you get an attraction to this point and then a repulsion on the other side. So it'll pull it in and then push it out before the next one comes into play. And that's the good part about it, there being 120 degrees, is because there's enough time for it to coast and let that push kick in. Oh, you mean like, well, I mean, there's a Howard Johnson motor out there that is said to be able to do the perpetual thing, but I don't know about it myself. I've seen a couple people try and build it. Uh, this definitely is not monopoling, though. It's you're just polarizing a rod, and it's. I mean, it could be useful, definitely. Honestly, I think it's great, man. I mean, things that I can do. It's like an extender for this magnet that allows me to range the magnet and not have it be directly influential in any of this. No, I don't have cheese, actually. Wow. What a question. I mean, am I supposed to read any deeper into that? I mean, oh, I'm glad I'm not having a bad night then. Welcome. Welcome. Yeah, I know that. Uh, Let me see. Yargnad. I know that, dude. Thank you. Thank you for stating the obvious, homie. See, now when it's really close, it's like, but if you can push it like hard enough to get over two humps, there's one hump right here. We'll do one hump. There's one, and it'll go around one time, maybe two. That's one hump. Now, if you get enough momentum to get over two humps, that's way too much. You just want to get over two. One, two. That'll go for 10 minutes. Hello, hello. Perpetual lotion does exist. I love it, man. That's awesome. I know all about entropy, homie. How about you? You know about it? Or you just read about it? It's that two hump trick, man. It'll keep going. No. Maybe, I don't know, man. It's let me just describe it for you. It's a piece of plastic with three cubical holes in it, and there are three neodymium magnets in those holes. It is resting, or it's glued to a toroidal magnet, and it's resting on another toroidal, so it's magleved. So it's very sensitive to any magnetic pull whatsoever. And then we'll back this out to the edge of the table. Now look at it, just want to go now. Yeah, hell yeah. Let me get the right side. This is north, this is south. So we're gonna go this way. Now that was like 3 humps. This is gonna go for the rest of the show, I think. At this speed, the neurons are gonna separate. Not 10 minutes. You're right. Very cool. Right. I think this one will go for a while, though. I feel like that guy in Jaws, and he like just shot the third barrel in him, and he's like, "You can't go down with three. Not with three, she can't." And it's like, you have no idea what you're dealing with. It's like I feel like I'm onto something, but I get it. Like I think I'm formulating the right answer in my head, and it's like I'm missing something. Totally missing something. I'm underestimating my opponent. Oh, well, uh, as you can see here, this neomagnet is resting on a coil. It's 20 gauge coil. It's about 1,500 turns. It weighs about 2.5 pounds. I make coils that run motors. Just these homemade motors, though. I got my 14-inch rotor right here. There are 12 neos in it. Big neos, like cylindrical monsters, man. And it's pretty cool. It's magleved as well. You can see it bouncing there. And then I've been getting into these shapes here, the Utrons. I want to get the tuning in here and tilt it on a 45-degree angle, and then uh, wrap a serpentine coil around the new equator. And basically the idea is the permanent magnets inside of there will trigger the electromagnets on the outside, which will then in turn trigger the serpentine coil, which will be wrapped around the equator of the Utron, which in turn will be wrapped in tinfoil, basically, for electrostatic effects. Whew, that one's going to be a nice project. This one over here, man. And it's got bearings in it that go like 28,000 RPMs, man. They're pretty nice. Um, what do you call them? Hybrid ceramic and steel. They're they're neat because they're missing one of the beads on the inside here. And you can hear it when it's going really fast. It starts knocking. I think these were made for the vertical pulse motor, like because when they're on the vertical side, you can really tell that the missing bead plays a big part when the gravity starts rolling. All right, do we want to see it go really, really fast? And do we want to see a pulse motor with a little bit of torque to it? And I do mean a little bit. I'm not being boastful here. All right, let me make sure this top one is off. It's off. Let's start it up. Now you notice the coil behind there is just, it's already ready to go. Woo! And this is a dual drive. So we're gonna let it get up to speed here, and then we're gonna turn on the second one, and we're gonna see how much the torque increases. So I'm gonna get it like just a finger torque reading. That's all I got right now. So that's what it's gonna have to do. And we're gonna let it keep going for like, we'll just talk it out for a few minutes here. So yeah, we're gonna let it. There's not much to say really. I just want to get it going fast, so when I put my finger on it, it doesn't stop right away. Okay, that was all right. I wasn't like dilly-dallying there. I was putting some pressure on that. So we'll let it speed up again. We'll turn on the second drive and we'll do it again. So let me explain that second drive thing, the dual drive. This coil has got two drives in it. It's got two 20-gauge strands and two 32-gauge strands. So each drive has got a trigger and a drive strand. All right, here we go. Let's turn on the second one. And they're both in the same coil, so that's pretty awesome. Now you are drawing twice as many amps when you turn on the second one. Voltage stays the same. We'll let it get going a little bit. Now you can already hear the torque on that increase. It's like whipping now. You can hear it. All right. I was really pushing on that. Like, not pushing, but definitely like, I can't move the rotor or I'll push the coil right off. So, I mean, I'm pushing as hard as I can, really. Actually, I think it goes a little bit slower when the torque part gets turned on, just because I think it hits like a fraction of a nanosecond later. So it's like a dual. But if it hit like right on top of one another, see, because now it's the one. And then I'll turn it back on in a second. Here we go. Where the hell is it? I'll have to find my tack meter, because I do have a tack strip on this one. Yes, sir. You know, I was looking at a blown out tire one time, like one that got literally just like it popped. And I was like, yeah, man, that's what happens when you go to the bathroom too fast. Hey, him, bro. Bruh, dang. All right. So we'll put some constant pressure on there, a little bit softer. Oh, that's awesome. But you know how many volts are going in this right now? That's the thing that's going to blow everybody's mind. Everybody's like, it's 12 volts, right? No, 6 volts. I think if I turn it up to 12, it's going to melt or something's going to get too hot. Heck yeah, man. Our Arduino, 5 volts. Heck yeah, monster truck. Oh man. And then of course, we got our pancake coil. It's not the best, but it works. Thank you, thank you. All right. I think that's great. And you know what's going on? The other cool part about all this is that it's charging a battery right now. And I bet even with only 6 volts in, it's still charging because of, I have both drives hooked up to the same battery through that cap bank device right there. So both of the drives are hooked into that, and then that's hooked directly to the battery. Well, the people who built that AC/DC flow bank, that's what I'm going to call it, are genius. Amen. Toy monster truck. No, I got a nice inductance coil that I built. Sorry, I gotta play with some wires. All right, so this is it right here. It's 4 inches in diameter, and it's about 1.2 pounds of copper. It's 24 gauge and 32 gauge for a trigger, and we're about to see that real quick. Inductance experiment to see if we can get better inductance with having a wider diameter coil. Oh yeah, and then the spiral? No, sir. I wish, man. Might have a fatter bankroll if this was free. See you later, recharger. Heck yeah, man. Let me get the downward look here. Because you got the outward flowing spiral, and then you got the inward flowing spiral real tight in the middle there. Whew. Nice and quick. Well, I don't know. I feel like I've covered a lot in 35 minutes. Like I've covered a bunch of stuff. That's awesome. Usually I'm stumbling over what I want to describe, but oh man. Huh. There we go. Let's see here. I want to keep this up here like that so that I don't have to bend over to get it. Now if this is moving, we can put this back in play. I'll turn it around. There we go. Thanks, Josh. Glad to have you. All right, so what I've done here, you can't really tell that it's polarized because the magnet itself reaches about that far. But if we push it all the way through, you got your south side here, and then that's going to extend all the way to the end of the pole. But you see how that's about how far it reaches. When you get out here, you're looking at field. But the polarized metal, you have to be right up on it to get a reading because it doesn't have a field that matters. All it is polarized, so it basically carries the pole of the magnet face that it's extending. And if you push it the other way through, you get the opposite pole. That's awesome. The 3D printer is a K1C, I think. So if you want a monopole, there's no field. Like I said, it's just a polarized piece of metal, so you can put that in the opposing field, and it'll change the trajectory of the magnets as long as you're free to spin. There's a lot of torque on those right now, even though it's still. Oh, it was a while ago I turned it off too. Like a lingering momentum that wouldn't be there if there wasn't torque. I don't know. I know this magnet is pretty cool. The washer, because you got your north and your south, right? Magnets, and you can either monopole them, which I do by polarizing the bar. So now that's all this face. It's an extender that you can reach the magnet out with it. So you can move the magnet itself out of range and just have the pole be in the field. But I mean, the usable range of these magnets because of the maglev are extremely far away, like sickly far away. So I don't know. I do know for a fact though that the bar gets polarized, and when you stick it in the field, see it get pushed, 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 back it out, pushed. But the washer is close enough to affect the magnets, no doubt. So I don't know the total extent of the effect. I just know that it is polarized. And now you can back it way out here like this and see if we get something. Like a nice push. Kinda. I can still kind of see it going, actually, but it's might just because I want it to be happening. I don't know. Hey, hey, hooray. I look myself in the mirror and I'm like, you old fool. Hello, Samantha. Samarth. Samarth. Ah, man, my eyes are going way gone. Sorry about that. I'm seriously trying to read this and I'm like, I can't really see. That's terrible. All right. See if we do that. So the magnet is totally in play. That's good. So all those magnets on the rotor are north facing out. So the south doesn't really come into play until it turns. So north out. We'll just push it one hump and we'll see if we can get 2 turns out of it. 1, 2. Wow, we're going to get like 5. Cool. Wow, is it going to do more than that? That's sick. Unreal. That thing wants to keep moving. All right. Let me make sure. South. So we want to go this way. So that was like a nice push. We'll see what happens. Hi. What's up, A? All right, so we got the disc on the top with the 3 neos north facing out. We got the washer with south facing to the right and north facing to the left. That's why I spun it that way. So when the north comes this way, the south will attract it, and when it passes here, the north will repel it. Or that's the idea. I mean, that's how it's supposed to work. And it will do that. It'll do exactly that until it stops. And then when it gets really slow, you'll be able to see it work that much more, that much better. So the problem with this is the closer you get it in, the more push you're going to have when it goes around, and more attraction you're going to have. But then you're going to have the south side of the magnets on the rotor more in play than they were before. So it's the give and take. You want to find the appropriate distance that your stator magnet is going to have from your rotor. Because you want it to push, but you don't want it to get bogged down. And the proper way to adjust that is distance. And then look at our big rotor up here, still spinning. All right, let's see. All right, so 12. the battery is charging. Awesome. So it's not like I'm just running it for my health. It's actually doing something. And when this one goes on automation mode, like when I turn it into a motor, it charges a battery as well. So it's not like I'm wasting anything really. And you got to also understand that the coil on the other side has got a lens effect. So this isn't like a true maybe I should move it. Let's move it out of the way. Try and do that without crossing any wires or anything. That's probably not going to be possible. Let's play some more with this. See if that helps any. I'm sure not having that copper there will help it move. Thank you everybody for coming in. I really appreciate all the people coming by tonight. That's awesome. You guys are great. So cool. I never thought I could be this fascinated by something moving so slow. So you got your south side, you got your north side. You got your north out magnets. But when you get too close to the north out, you got a south. See that south bubble starting to pop? Definitely, man. There's always going to be that south in between the north and the north. Unless, now, me and my brother had this crazy idea that we would take a 9 magnet rotor with the cubicle slots, right? And we would fill the 2 spots in between each of the 120s with iron. We'd fill those slots with iron to negate the south in between. Just have 2 iron, basically iron cubes, and put them in those slots and see what happens. And what I think is going to happen is that that iron is going to absorb that south. And yeah, I think it'll be awesome. Even though they're not directly touching the magnets, I think that it will absorb the field. And let me show you just the one that, because I've already got it built. It's the green one right there. See, you got 2 cute spots in between each magnet to put the iron. And then that will prevent that south bubble from popping out. And that'll just be awesome. I don't know to what avail, I don't know. But I can see the south wanting to rear its ugly head here. See that? Definitely a thing. So I don't know. That's our idea. Fancy, fancy. Only this is just a permanent magnet machine, really. It's not a, right now it is anyway. Yeah, it is. Yeah, absolutely. Not like you're suggesting, but in this regard, it rears its ugly head. Let's get it in there. Let's get it nice and in there. You can see a rocket now. It's like moving the magnet so in the field. I don't know, like more than a gallon of gasoline. Still, I think. It's really close. It's about the same price. Ah, for sure. Sorry, Josh. I didn't mean to assume, man. I'm totally. That was my bad, dude. I did not mean to assume. But do you understand why I did? I mean, I did make a mistake, but I feel like it was an honest mistake. Yep, right around $4. A little under $4. Okay. No, yeah. Yeah. Just reminded me of a group I like to listen to named Pantera, and they did that Southern Trendkill uh, record a while back. I love them, man, and Down too. You know, like two of my favorite groups. And I think that somebody gave me like for listening to Nine Inch Nails the most. I got like some sort of reward. Unreal, dude. Hey, Mike, what's up? All right, let's see what we got going on here. North. Friday night. Oh, there's a game called Friday Night Funkin'. And it's a piano game, I guess, or a keyboard piano game. It's pretty neat. Heck yeah. All right. So with this Neo wash, oh my God, it feels tingly. Oh my Lord. Wow, that's weird. Okay. With the Neo washer here, we can polarize this rod. So that's all North Pole. There's no field. As you can see, like I click out here, there's nothing out here. But when I get it right up on it, it's polarized now. So I don't know, like, to what avail it will have, but you can see it, like, interact with the magnets. Yeah, man. That's the only reason that this thing will even respond the way it does is because of the maglev. And that magic disc that I have makes it so easy to do. All right, I'm gonna let you in on a little secret, everybody. Um, there's a company that makes discs with a center hole in them. You can get 2 inch, 4 inch, 3 inch, 5 inch, 6 inch, 7 inch, 8 inch, all the way up to 10 inches with the center hole. You can get the center hole custom made to be whatever size you want your bearing or whatever. And I got the 1/4 inch center hole and the 4 inch disc, and I put a bunch of magnets on the edge of the disc. And now on my 1/4 inch poles, on my 1/4 inch shafts, I can center the two toroids like damn near perfect. So that's it, man. Having that center hole on a 4 inch disc is all it took. And then some magnets, of course. You gotta get it so it'll stick to the magnet, and then it'll center it. I was like, damn, how am I gonna get this thing centered? Because it's like I got all these ceramic magnets that I can like levitate stuff with, and it's good levitation. But how do I get it so that it's not flopping all over the place? Because if you don't line those up, right, it's not gonna do what it's supposed to do. So how you been, Mike? I think it's carbon fiber or carbon metal of some kind. It's got a high iron content. The iron pole does, and the putting the iron pole through the washer polarizes the iron pole to whatever side I choose to poke it through. So right now it's probably north. You see, it interacts with the field very well, but you get it too close and it becomes an iron rod again. So there's lots of forces being, at play here. It doesn't have a field though. The iron rod doesn't ever have a field. It can do either or, but it doesn't have a field. It's only polarized. I'll show you what I mean. Stick it all the way through one side. All right, so a field is out here where the magnet is. It's away from the magnet. But we get this up here close to the rod. It goes all the way down. But if you get it a little bit away from the rod, nothing. Up close to the rod. See, it's just polarized. It's not, doesn't have a field. And if you call that, I would not call that a field. I would call that polarization. Wow. No, we're too close to the magnet here. There we go. Well, I'd say it's less than a centimeter if there is a field. Way less. Yes, it can do that simultaneously. If you get it close enough, it'll do it simultaneously, I mean. But right now, it looks like it's only at there, right there. See? But you got to give it some momentum, and then it'll do what I think you want to see. I'm not sure, though. You back it out a little bit. All right, so that might be, is that south? I don't know. I haven't shot the thing at it yet. No, that's north. Okay. That makes sense. See if you get it really close. But, you know, I didn't think that was my objective to do it like that. Um, let's see here. Let's back it out a little bit. What I'm trying to do is just get it to interact with the field, like the monopole part, like just the polarized part. You see how that's working? There's barely any drag there. But that's from the repulsion. You know, it moves up to the rod and then it gets repelled if it's not strong enough to overcome. Yeah. And then we'll do a traction mode. Yeah, you can see the difference there. Wow. But yeah, the repel and attraction thing, I think, I don't know, I haven't like seen it work real well. Maybe it's because I need to give it a little push and then it'll work better. Oops. Sorry about that, guys. Yeah, that I understand the let's give it a push and see what happens. So we'll go counterclockwise and we'll get it in there. Oh, look at that. So is that too close? I think that's too close. Wow. It's very magnetic. No, I don't have to. And I would definitely try that. Absolutely. Mm. And it would probably double the strength of the almost non existent field, which I would just like to call polarization because it's not. It works better when it's in the field than it is when it's in the presence, basically, of the magnet. But what I've been finding to work very well recently is just putting this washer on the side, on its side like this, moving it in a little bit, and getting that push pull effect. See, so when you got your traction phase, when it's run this way, and it'll attract it, and then it'll push it out the other side, and it's 120. So I think the only one that'll do it better than this is a 180. Hmm. And when it's permanent magnets, I don't trust anything that's going fast. Nothing. I think it's great. And yeah, that's sure. Whatever, dude. My brother told me to like link the stuff that I do to what's going on in the world today, but I don't even fucking pay attention. I really don't. I mean, I've seen a V-gate, but this does not remind me of that. Yeah, I get it though, the south and then the north. I get it. And that's really cool that I didn't even have to look it up and it kind of coincides with other stuff. That's great. I think that shows a sign of my intellect. That's what that does. But I always got to check because I think I'm a fool. I think I'm stupid. Yeah, it's not a motor. You want to build a motor like this, talk to Howard Johnson. Or he's not around anymore, but you know what I mean? Look up his stuff. You won't find one of these in there. You'll find monopole magnets, I guess. Maybe like that. Maybe you'll find one of these in there. I don't know. Maybe. I have no idea. I didn't think that the V gate was no. I don't think that at all. I think you got to hook it up to a bunch of other stuff for it to be like even a viable thing. Like Robert, I believe his name is, has put it forth very clearly. He built one. You know, he made one. He hooked it up to a bunch of stuff. It isn't what people think it is, basically. But yeah, I get that, kinda, sorta. Except the magnets in the V gate are the thing that's moving on the drum. So I don't know. Maybe it's just reverse V gate or something. Well, yeah, no, it's all good, dude. It's not what you think it is, but it's awesome. I forgot exactly how he explained it, but he did not explain it as a perpetual motion machine. I believe that it is a proven concept, but it's not what people think it is. That's all I said. Yeah. Um, mm, Oh, that's pretty cool. Our battery's up to like 12.22 now. It was at 12.15, now it's at 12.22. Big rotor's doing his job. Inductance coil's doing his job. Yeah, I'm not into. Nah, I don't care. I'm not spending any more money. Yeah, well, I see. I had the pleasure of living next to a university called Michigan Tech, and that's what they do there. They make space age polymers. They make all the new shit at this place. So yeah, I know what you're talking about. And no, 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 man. There's no game changer coming. I mean, there is. It's going to change the game, but none of the old stuff is going away. That's what I'm trying to say. Just the stuff that costs too much to maintain. Super space age alloy is definitely coming though. I was wondering like if you could use a Tesla coil and small amounts of graphene that you could get with the pencil and then structure the graphene into a liquid using a liquid and the graphene and a Tesla coil. And then you could coat, like my paperclip switch, you coat that in a graphene liquid, and oh my God, man. I mean, the conductivity of that little spark is going to go through the roof, man, through the roof. Because right now it's pretty unstable. My paperclip switches are unstable when it comes to charging. I mean, they don't even take 100 millivolts to run it, like 16 uh, volts in, 100 milliamps. So it's like the meter still says zero, basically, uh, and it's up at 16 volts. And I'm like, damn, this isn't going to charge shit. This is not going to charge anything. You got to have a little bit of current to like push it into the battery. You have to have current a little bit. All right, all right, all right. Nah, dude. You want to buy this? Nah, Mike. Come on, bruh. You got to save some of those magnets for me and anybody else who wants them. Yeah, if you don't see it that way, I'm going to have to open your eyes. So neat. But I don't know. It is kind of getting old a little bit. I mean, not like that. I mean, I'm getting tired, and now all the arguing is coming out. I don't know, man. I think we're going to have to call it a night for now. It's been really awesome. I'm so happy that everybody came out to play, man. That's awesome. I really appreciate Mike coming out. Josh, thanks all. Chase, everybody that dropped a comment, man, I appreciate you. Everybody who didn't, I appreciate you. But you know, I love to try and read this stuff. Like I said, I can't see, but I mean, yeah, I don't know, man. It's good. It's all good. All right. Well, have a good night. Peace out. Stay cool. Uh, Bye now.